In this problem, I am going to go through a calculation that shows how to calculate how much of the different components of a buffer you need to add in order to make a buffer of a desired pH, molarity, and volume. So in this problem, we are asked to use an acetic acid and sodium acetate buffer. And we want to prepare the buffer with a pH of 5.00 and a total concentration of 0.500 molar. What that means is that the concentrations of the acetic acid and the sodium acetate, when added together, need to equal 0.500 molar. And then the total volume of the buffer is 125 milliliters. So, okay. This seems like a lot of information. It seems like it's hard to know where to start. But my first thought is, well, I am asked to prepare a buffer, first of all. And so that should trigger the Henderson-Hasselbalch equation, because that's what we use when we deal with buffers. But also, it relates concentrations to the pH, and that's what I'm being asked to do here. There's a couple more pieces of this, but that's the big idea. So if I write down the Henderson-Hasselbalch equation, pH equals pKa plus log of the conjugate base over the acid. Okay, and these again are initial concentrations, so they're not taking into account the reaction with water. They're just the initial concentrations of added A minus and HA minus, or HA, sorry, not HA minus. So I know the pH, I know that, and if I can find the pKa, which should be listed as easily findable, then I should be able to get to at least the ratio of the concentrations of the A minus and HA, and then from there maybe I can figure out a way to get to the actual concentrations of each of those components, because I know they have to add up to a certain amount. Once I know the concentrations, I know the total volume, I can figure out the moles, and from there figure out the grams. So that's my overall problem solving strategy, is find the ratio of A minus over HA, and then using the Henderson-Hasselbalch equation, and then I need to find the actual concentrations of A minus and HA, and then the third step would be to find the moles of each, and then from that I can find grams. Notice that I didn't talk about any calculations in my strategy. I just talked about what are the general steps I'm going to do, what are the general things I need to find. If you plug in numbers and start thinking calculations too soon, then you might get lost and forget about what you're doing or get stuck. But if you have a general strategy that you can write out in words, that's going to help you. Okay, so the first thing that I'm going to need to do is find that ratio of the two different concentrations. And so I can plug what I know into the Henderson-Hasselbalch equation, but I notice that I'm not given the Ka or the pKa of the solution. And so what do I need to do? Well, I need to find it somehow. And if I look it up, and you'll be given this information on exams, either in the form of a table or just given it in the problem. If I were to look up the pKa of acetic acid, then that would give me, so pKa of CH3COOH. Remember, the pKa's are always for the acid, not for the conjugate base. This is 4.75, so that's just something I looked up. Okay, so let's think about this. Our pH is going to be higher than the pKa of our acid. And so what needs to be in higher concentration, the acid or the conjugate base? Well, if our pH is going to be higher, that means it's going to be less acidic, more basic, than if it was equal concentrations of the acetic acid and the conjugate base. Remember, if they're equal concentrations, then the pH equals the pKa, but the pH is more, so it's looking like we're going to need more base. So let's just keep that in mind as we go through our calculations and see if our calculation makes sense in the end. So what am I solving for? I'm solving for the ratio of the A minus to the HA in the Henderson-Hasselbalch equation. So let's isolate that. Let's say log of A minus, and I'm just going to forget about the I's. I'll have it in my head, the initial concentrations, equals pH minus pKa. Well, that's easy enough to do. That's 5.00 minus 4.75. That equals 0.25. Okay, so we're on our way there. So now how do we simplify this? So the log of this ratio equals 0.25. That means that the actual ratio of the concentrations equals 10 to the 0.25. That's how I simplify a log, okay? I take the thing that's hanging out at the end of my equation, and that is my power on 10, and it's the power of 10 because it's a power of 10 log, not a natural log. Okay, and then that gets rid of my log on the left side there. So if I plug this into my calculator, I will get 1.778. So now I know the ratio of A minus to HA. So good, I'm making progress. So then how do I find the actual concentrations of my A minus and my HA? Well, I have this other piece of information here that says that the total concentration equals 0.500 molar. Okay, so I can write an equation, A minus plus HA equals 0.500. I'm going to leave out units in my calculations just because there's a lot to write down, and I'll put them back in the end. So now I have two equations. I have this equation and I have this equation. I have two unknowns and I have two equations. So it seems like I can put those together somehow to solve for the concentrations. Okay, and you can do this in any way you want to. So you can either solve for one of these things in this equation and then plug it into the second equation, or you can solve for one of these things in the second equation and plug it into the first equation. I am going to, let's see, I tried it both ways, and they're both about the same. But I'm going to take this first equation here, the one that says the ratio, and I'm going to use that to solve for either A minus or HA. A minus seems easier, and then I'm going to plug that into the second equation. So if I solve for A minus using that equation, I get A minus equals 10 to the 0.25. Oops, well, we already calculated that number. Let's make it even simpler. So A minus equals 1.778 times HA. Okay. So now we have A minus expressed in terms of HA. We can now plug this whole term into the second equation. So this is just solving using systems of equations. And so if I do that, I get 1.778 HA plus HA equals 0.500. Okay, and so I'm adding two HAs together, so it looks like I can simplify this to 2.778 HA equals 0.500. Okay, and so this is an equation that now has one unknown in it, and I can solve for that unknown, and what I end up getting if I simplify this further, so if I want to solve for HA, I would take 0.500 and divide it by 2.778. This gives me an HA concentration of 0.180 molar. Now I can use one of my first two equations, one of my start equations up there, to calculate what A minus is. And it seems to me like the simpler one, well, I don't know, but I guess both are pretty simple. But the second start equation here is telling me that A minus should equal 0.500 molar minus 0.180 molar, because the two have to add up to 0.5. And so this is giving me an A minus concentration of 0.320 molar. So let's look at this before we go on. Let's see if it makes sense. Which one is in the higher concentration, HA or A minus? Well, it looks like A minus is in the higher concentration here. Does that make sense with the pH and pKa relationship that we have? Yeah, because the pH is higher than the pKa, so we need more base. So that makes sense. Just a note that when you do this, you could end up getting a negative value for the pH minus the pKa, and that's fine. You can take 10 to the negative value and get a number less than 1. So that just means if it's a negative value, that just means the pKa is bigger than the pH, and you're going to have the acid in the higher concentration. So pay attention to the order in which you subtract those two values. It's pH minus pKa, and you have to pay attention to the chart, that positive or negative sign as well.